You hear the siren, you hear a bang, and then you hear a whoosh. It goes bang, bang, whoosh.
Hi, I'm Lily Serna. Growing up in Sydney, I was always fascinated by numbers. How numbers made sense of the world while also blowing it wide open. That fascination with numbers has never stopped and led me to a lifelong interest in technology and STEM. I'm so excited to present this series, Technically Possible, a place where we get to dive into Australia's defence industry, where some of the world's greatest technological hopes and dreams are made real. Presented by BAE Systems Australia. We tell the stories behind some of Australia's greatest defence technologies. We reveal the depth of innovation, passion and perseverance that has made Australia's defence industry in recent times. We talk to the people behind the technology, as well as the people who use it daily in their work to defend life and limb. And for this episode, let's start with a bang.
Certainly the Nulka system as it is and how it's been designed is a very, very effective system. It does its job very well across many aspects of not just the flight vehicle, but for the payloads that it carries. It does a very good job. It's very effective and it's very quick.
Rooted in Australia's defence history, Nulka has become one of Australia's biggest defence success stories. A soft-kill defence technology with an Indigenous Australian name, meaning be quick. More than 1,000 Nulka systems have been delivered, bringing in more than $1 billion to the Australian economy. And it was born on the outskirts of Melbourne. Nulka is a rocket packed with electronics that's fired by a ship under missile attack. Once released, it hovers in the path of incoming missiles. It then emits signals that triggers a radar return from a large ship. This ghost image of a ship overlaps the targeted ship. Once the incoming missile locks on, the Nulka rocket moves the ship away from the real ship. The missile then follows it into empty space, saving the intended target from attack. So, how did this technology come about? For that, we need to travel some more, across the vast expanse of the Pacific Ocean to a small archipelago, 480 kilometres off the coast of Argentina. It was there on a calm and fair morning in 1982. The HMS Sheffield was on patrol in waters surrounding the Falkland Islands. The islands were the disputed claim between Argentina and Britain. The previous month, Argentinian military forces had invaded the islands they call Las Islas Malvinas, claiming British occupation as unlawful. The British-guided missile destroyer HMS Sheffield was at service to defend the islands against this attack. In the 2 weeks prior, the Argentinian military had been trialling a new kind of missile. The French-made Exocet missile was named after a fish that sometimes flew into a boat. A missile that flew low in the air, around 30 metres from sea level, undetectable by HMS Sheffield's radar until it was too late. On that calm May morning, the Exocet struck the destroyer's starboard side, killing 20 of its crew and injuring 26 others.
There was a lot of British ships sunk by the Exocet missiles that the Argentinians used. And Exocet missiles were missiles that were growing in number around the world, so it was a really significant threat.
Such threats forced manufacturers to rethink missile defence.
US Navy ship in the
Brad
Gulf.
Yelland is Chief Technology Officer for BAE Systems Australia and talks about the collaboration between the Defence Science and Technology Group and AWA Industries, which later became a part of BAE Systems Australia.
Not long after that, the USS Stark, US Navy ship in the Gulf, was sunk by a different version of an anti-ship missile, but a similar sort of techniques. It was a Chinese-developed Silkworm missile that was fired by an adversary in the Gulf area, and the US realised just how much in danger their ships were against these threats. They'd heard through the technology sharing programs between our defence science technology organisations of the work that we were doing in Australia between DST and government aircraft factories, and decided that that was a good solution, and so offered to start funding the program. And that's really when it turned into a big program. We then got a lot of visibility as to how effective it was, what a valuable product it was, and we got a lot of interest from different navies around the world.
But Nulka, or Winnan as it was known then, was competing for defence spending against many other important projects.
Yeah, so back then it was a project that was funded by what they called trickle funding, which is basically government aircraft factories as a federal government funded organisation, public service. And there was budgets allocated each year, and when it was clear that there was some spare budget out of other projects, it was allocated to the hovering rocket concept program. So we were survived under trickle funding for quite a few years. I think everyone was waiting really to see whether anything would come out of the hovering rocket concept, because it had never been done before, and they didn't want to spend huge amounts of money on something that until there was a bit of certainty that it would work.
After the sinking of the HMS Sheffield, priorities began to shift.
You don't listen to him. You can't take it.
At this time, Kim Beazley was Australia's Federal Minister for Defence and tells the story of an encounter with Caspar, or Cap Weinberger, who was US Secretary of Defence at the time.
The Honourable Minister.
We were probably in those days the second or third best defence customer of the United States in terms of value. I think the F-18 had sort of shoved us right up the list, but we were buying a lot of other American kit as well. So, and the Americans just wouldn't buy anything from us. It was annoying to our manufacturers that was the case. We were just beginning to move beyond simply being producers of artillery pieces and ammunition, rifles and ammunition and so on, and to a more sophisticated end technologically, but weren't getting very far with it. Anyway, I made all our normal complaints, and Cap suddenly says, "Look, Kim, I'm sick of you always grizzling whenever you see me about how we don't take any notice of what you're doing. Just give me an example. I want an example of it." And so I had a brainwave and I said, right. And I pulled out of my, because it was in my bag, though not amongst my briefings, I pulled out Winnan and said, this is is a hovering rocket that we're supposed to be developing, and you have lost interest in it. Right, said Weinberger, it's done. We will be doing it. And he turns around to his people who are sort of waving their hands behind him, who had obviously talked the whole thing through with our people, and they'd all mutually come to the view that they wouldn't waste money on it. And they started to mumble and jumble about it and indicate opposition. And Weinberger said, there's going to be no opposition. I don't care what you think. He says, I want you now to simply make this happen. That was that. So it was both our people and theirs were not completely happy with that outcome. But nevertheless, I went on with it, and I guess the rest's history.
As one of the biggest spenders on defence in the world, the USA's involvement in the Nulka program was critical to its success.
In the development process, we got to the operational evaluation trials, which is where the US and Australian navies took it away and tested it in a real-world scenario. We weren't allowed to see the results of that. That was sort of highly classified defence-only results, and the trials the US did were US eyes only.
This partnership with the US proved to be greatly beneficial on a number of levels.
The US Navy put a full-scale production contract on us, and because the US Navy had funded a lot of the final program, it came under the export restrictions of the US State Department. Then on the other hand, if you can only have one other customer, the US Navy is the customer that you really want, and we managed to secure that. Still today, we're the only non-US prime contractor providing a system to the US Navy. And that's really a good indication of just how good Nulka is and how important Nulka is to the US Navy and to the Australian Navy. So as a result of the export to the US Navy and to some extent the Canadian Navy, but the US buy a significant number of Nulkas, we've actually delivered well over $1 billion worth of exports back into the country, which is economically it's really successful, the most successful defence export product that Australia's ever produced.
And this impacted a number of Australian suppliers to the defence industry.
In the Australian environment, we've got some really top-class suppliers, small companies, SMEs as we call them, who have got really great capability. The problem is getting the volume to make it sustainable. So what Nulka gave us was an export customer that allowed us to achieve that volume where those small companies could be self-sustaining and actually start to invest back into their business to develop more capability. So one of the really good things that's come out of the Nulka program is that whole expansion and growth of the Australian defence industry and the SMEs. That's the sort of thing we should be aiming for as a nation. And I know the government's got to focus on export, and that's exactly what we need to do to make it self-sustainable.
I think the advantage after conceiving, developing and designing Nulka, it's not just the fact that it's an effective and sophisticated weapon, but the fact that we could produce that here gave us enormous stock and credit with our closest allies as to the abilities that we can produce here in Australia, and that should not be underestimated.
Vice Admiral Tim Barrett is the former Chief of Australia's Navy with over 40 years of service. I met up with him at Garden Island shipyards on a perfect Sydney spring afternoon. I asked him about the change in thinking that happened after the Falkland Islands War.
I think there was always a thought among the community that we needed something like Nulka. By that stage we didn't have a name for it clearly, but the idea that the procedural side of our training would not overcome all threats and that we were needing a technical solution. What that looked like at the time was not clearly defined, but eventually, and over a prolonged period of time, Nulka emerged as the sophisticated and the right solution for that particular threat.
So what were your experiences with Nulka when it first came about and ongoing?
Well, I was at sea in an aviation role by the time that Nulka actually featured at sea. And it was interesting because some of the outcomes of the Falklands War actually use helicopters as means to try and seduce weapons away from ships. And so, ironically, there's always a thought that I could be sitting in a helicopter trying to seduce missiles away from hitting the ships. So it was a nice thought that Nulka would come along and actually do that on our behalf, rather than put other capabilities at risk. So it was something we had observed over a period of time, slowly develop, and then I actually saw its fundamental use at sea. There's a sense of relief because now there was a sophisticated and a very capable weapon to be able to counter the weapons that might be used against us.
The nature of Nulka's design meant that ships could be better protected in an almost intuitive way.
I think the beauty of Nulka is it was melding a number of different significant technologies. I mean, I spent a lot of my career in helicopters in the hover, but who would ever have thought that you could actually have a rocket that would hover alongside the ship in a manner that could simulate how the ship might move. So the technology that was required to do that was profound. And then you topped that rocket motor with an electronic warfare capability that had a sophistication to defeat the most sophisticated weapons that others around the world were developing as a way of drawing the threat away from our ship.
The story of Nulka is not just about the technology, but about the people instrumental in a development that spanned decades.
Hello there, my name's Mark Cooper. I'm the engineering manager for test and integration at BAE Systems Australia. I actually spent quite a number of years on the Nulka program, and I was involved with a lot of the sea trials and acceptance into service of the Nulka decoy and the Nulka launch subsystem.
Mark was, at the time, what's called a sea rider. That's someone not part of the Navy who goes out with the ships to conduct tests. In this case, to independently observe and analyse the data on the Nulka trials.
Being a sea rider on the Nulka trial is quite interesting and really, really important for people, for engineers like myself who don't get necessarily to see the products they design and develop being used in the end environment. And it was a great privilege to be involved in the sea rider trials. Got to meet a lot of the Navy personnel that use the system, and what it really imparted on me is the importance of doing a very, very thorough job.
So what was it like to be on board these trials?
The sea rider experience is certainly not for everybody. Touch wood, I didn't get motion sickness, and we had some pretty rough trials weather-wise. But what was involved is setting up some scenarios, and some realistic scenarios for the use of the system, where we'd exercise not just the decoy itself, but the whole launch subsystem and all the shipboard equipment. Often that involved having simulated targets fly into the ship, and it exercised not only the system, but the training of the crew, the way that they communicated with each other. It was actually quite often a tense environment, a high tempo environment. And my role then was on board the ship is to have a look at all of the data coming off the decoy. So in those scenarios, there were aircraft that were simulating threats coming in, and they would come in and simulate an anti-ship missile. The aircraft would come in low and fast, and the crew would go through their drills. And certainly for all the trials that I was involved with, you'd hear the launch. The launcher actually has a siren or a speaker attached to it. Once the decision's made, the particular decoy is chosen, the launch sequence just takes over. A siren is sounded, the top cap pops, and away it goes. It's all very quick. Yeah, got to hear that sound many, many times. Actually, it's actually quite hard to see out because it blends very nicely in with the greyness of the sea. But it's like, if you can imagine holding a pencil in front of you and tilting it over and moving it, from left to right. That's what it looks like, and it's absolutely rock solid. Despite all the ship motion and the waves and the wind and all the variations and all the environmental conditions, it's absolutely rock solid.
It's an extraordinary thing to watch. And as I say, who would ever thought that you could create something like that? Who would even have imagined that someone would come up with such an idea? But it has, and it's so effective. And that's the beauty of seeing this. I mean, some people would just see it as a metal canister. There's a real beauty in the fact that this thing performs like the lunar module trying to land on the moon. This really is rocket science, and we've got people here who developed and designed it.
Again, the success of any technology comes down to the people who design and operate it. What kind of skill sets does it require to build something like this? Because I imagine that it's a broad range.
It takes someone who doesn't just look at a problem and think of a traditional solution, but someone who is brave enough, courageous enough to think broadly over how it can be done differently. Before you even start contemplating what the technical possibilities are, you need to imagine that something could defeat a weapon in this way, doing something that many people would not even have considered. That takes a certain skill. But then to translate that into drawings, design, test programs, resolve needed to put this through what is a long period of time and a confirmation of the methodologies that you use in the design, stamina. It takes all of those things beyond purely the engineering prowess or the scientific know-how as to how you might do this.
One of these people is Rachel.
My name's Rachel, and I was a systems engineer on Nulka for about 10 years. So we went to the US as part of a trial. We had created a new sensor suite and we wanted to try them out in flight. So we went over to the US to fly them at one of the military ranges over there and to get some in-flight data from the sensors that we put on board. We got the flight data from the vehicle and we extracted it after the flight, and then we were able to assess the sensors' performance in real life flight. I found it a really great experience. A lot of the people felt very passionate about working on that product, and you believe it as well. There was a lot of people who'd worked there a long time, and their passion sort of really flowed through what they did and the way that they taught other people to do engineering. So it was a really great experience, both as like a person and developing engineering skills.
This passion that Rachel's talking about is something she still carries.
To see that go from being a concept, an idea, that this crazy idea, let's see if we can put some sensors in these vehicles and get some real world data, to then putting that product together and all the design artifacts in order to do that, and then deploying it in a real life trial was great.
The nature of these projects means that it requires a broad range of skills and people.
As a program, it wasn't and never was a large program, not compared to some other programs. It did involve a lot of collaboration between industry, the scientific community, the government scientific labs, the services and the governments at the time. It was a very collaborative project, a very high level of trust and a very high level of mutual respect amongst all the participants and the skills and what they brought to the project. It was a great project from an Australian industry point of view. It brought together some very unique skills and still does.
The right frame of mind makes the crucial difference.
Well, I think it's always sensible to say that you need, from an engineering perspective, for someone who's going to work on something like the future Nulka, you're going to need to have those technical abilities behind you to know what is possible now or what might have potential. But I think one of the broader issues is have a mindset that says, right, the whiteboard is clear. We're not here to build another of the past version. We're here to completely change the nature of how this system might work. Or is that indeed the right system to defeat this problem that we have been given? And that might lead to something entirely different in a different shape, space, time, or whatever. That's what happened with Nulka right at the start. People were bold enough to not be drawn down a view that says you need to counter a weapon coming towards you by firing another weapon at it. That is a hard kill. And it allowed people to think broadly about this thing called soft kill, which was to seduce the weapon away from your ship.
This expansive approach will be applied more and more as we look to future innovation.
Whether the future will look exactly like Nulka, I can't tell. But what was learned, and the fact that we had such great minds to produce those two sorts of technologies, encourages me that we will find a solution that might look like Nulka, or it might look like the next follow-on from Nulka, but we will have a capacity to innovate, to produce what is needed to keep the community at sea safe. And I think the Nulka program gives us a lesson here. The issue will be to give the people in that community as much as is needed for them to be able to experiment and on occasion fail, but then to keep going, to pursue all these ideas so that one of them will work and will be the future Nulka. And I do see that that's something that governments, companies and defence need to do in the future so that we don't end up with protracted periods from those very smart and clever ideas and concepts that young engineers and scientists think of, and even older scientists think of, before we see it in practical use at sea.
It'll continue to evolve until the threat changes to the point where something like a Nulka is not useful anymore. It's the type of system that is very adaptable to meet the changing threat environment. And that's the reason it's been around for 30 years, and that's the reason it'll be around for another 30 years. The development of Nulka allowed us to develop some quite significant and world-leading capability in guidance and control. We then realised that was a capability that was useful in other areas, and we actually looked at a whole range of other areas, and the obvious one was in guided missiles. And just at that time there was an opportunity called Evolved Sea Sparrow Missile, where the Australian Navy was part of a NATO program to do a full-scale development of the existing Sea Sparrow missile, and Sea Sparrow is effectively what we call a hard kill version of Nulka. So Nulka is a soft kill, so it uses electronic means in order to protect the ship, whereas Sea Sparrow or Evolved Sea Sparrow missile uses kinetic methods. In other words, it's a missile; it blows up the missile that's coming in. So that was a program that the Australian Navy was involved in. They wanted to put Evolved Sea Sparrow missile on the Anzac frigates. So we had the opportunity to secure a role on that program as the Australian work share into that program, and we conducted a number of studies around novel concepts for guidance and control of missiles. And when the US prime contractor saw the studies we did, we were offered the role of the guidance and control solution development for Evolved Sea Sparrow missile. When I look back on Nulka, I feel very proud. I mean, when I was a graduate and put onto the hovering rocket concept program, I was an aeronautical engineering graduate. I specialised in aerodynamics, and all I could see is the program I was put on was basically a pipe, and how much aerodynamics could there be in a hovering rocket. And so I was pretty disappointed as a graduate that I was put on that program compared to the other programs that were going on at the government aircraft factories. But I pretty quickly realised that what I was lucky to be put on was something that was a pretty exciting and absolutely world-class, world-leading capability. And to this day, I can't believe my luck, and I feel extremely proud and feel like Nulka's mine, really. I mean, there's a lot of people around Australia that can say exactly the same thing, because it's involved over the 20-odd years, it's involved 30-odd years, it's involved a lot of people in Australia. It's great if that many people actually feel the same way as I do, that we can be really proud of Nulka.
Turning technical dreams into awe-inspiring reality. Technically Possible was produced by BAE Systems Australia. Thanks for all who contributed to this episode, our researcher and journalist Tori Shepherd, our guests for sharing their stories and insights, our producer from Audiocraft, and to you who listened to it and stayed on until the end. In our next episode, we dive deep into a shipbuilding boom and a technology transformation to ask whether Australia can become a true maritime power. Technically Possible is available via your favourite podcast app. To share your feedback with us, find us on social media, BAE Systems Australia, or drop a line to tppodcast@baesystems.com. Music for this episode is by Epidemic Sound.